we will be discussing a very interesting subject, the spherical mirrors. So as the name suggests, spherical mirrors. This mirror is a part of a huge sphere. Okay, for example, suppose I'm drawing this is a sphere and this is a part of the sphere. So this is a spherical mirror. Now, as we know that every sphere, every circle has a center. So this is a center. This is known as the center of curvature. Okay? And so this is known as the center of curvature. And if we draw a line through the center of curvature and the midpoint of the lens, whatever lens it is, we get a point which is known as the pole. Okay? And this distance, mn, this distance is known as the aperture. Which aperture is the area of the mirror on which the light can fall. Okay? Great. So you see, we have now got 2 points, the center of curvature and the pole. Now, a very important term we have all heard about, the focus. For that, we will need the type of the spherical mirror. So there are 2 types of spherical mirrors, concave mirrors and convex mirrors. Concave mirror. See the cave part in this mirror. So that's why I remember it. You can remember it this way. That the cave part which is reflecting the light is concave mirror. And this is obviously the non-reflecting side. And this is the convex mirror. Over here, this is the non-reflecting side and this is the reflecting surface. Okay? So now, in case of a concave mirror, let us see where the focus is. What did we name this? This is the pole. Suppose here is the center of curvature. And the line which joins the center of curvature and the pole is known as the principal axis. Okay, so this is the principal axis. Now we will have incident rays. Okay, now in a concave mirror, the reflected rays always converges towards a point. Okay, it converges towards a point. So they will converge towards a point. This is the principal focus, the point where all the reflected rays converge and meet. Okay, this is the principal focus of a concave mirror. Now usually the distance between the pole and the principal focus is known as the focal length of any lens or mirror. And the center of curvature for a very small spherical mirror with small aperture. You remember what is aperture? This distance. This distance where the light can fall. This is known as aperture of the spherical mirror. In this case, a concave mirror. Right. So, in some cases, when the aperture is very low, the distance from C to P, that is from center of curvature to the pole, is twice the focal length. So R is the radius of curvature and small f is the focal length. Okay. Capital F is the focal point. Small f is the focal length. So don't get confused for those who are learning this new. So this is the principal focus for a concave mirror. Now let us see what will happen in case of a convex mirror. We will still have our pole over here. We will have our C, right? Because it's this curve, so C will be over here. So this distance is the radius of curvature, and this is the center of curvature. Very well. So now we will let light fall on the convex mirror. Now you see, as the curve suggests, a diverging curve. So the reflected rays will diverge here and there. Also, you should remember that, So you see how the incident rays are parallel to the principal axis. Okay? It is because we are taking the light, we are assuming that the light rays are coming from a source which is at infinite distance from the mirror. So all the rays are parallel to the principal axis. And the reflected rays are diverging. And it appears as if it is coming from a point behind the mirror. Now this point where the reflected rays appears to be coming from is known as the principal focus of the convex mirror. Okay. Now I can actually show you why concave mirror is convergent and convex mirror is divergent. Sorry. I hope you have heard that a sphere or a circle is made up of very small straight lines, right? And do you remember the laws of reflection? Good. So suppose this is a small straight line, right? On the mirror, on the convex mirror. So now, light is reflecting, right? Light falls, right? So, appearing from this figure, which side do you think it will reflect back to? Obviously this side, now. Because of that, because this is the normal to this reflecting surface. This black dotted line is the normal on this line, right? So, this is the angle of incidence and this has to be the angle of reflection. I cannot just draw the reflected ray to this side. I'm sorry, I have wrong. Okay, so that is how you can see, that is why you can see that on a convex mirror, the reflected rays will always diverge away from each other. And in a convex mirror, due to the same reason, because of these normals I can draw on the spherical mirror, the reflected rays are convergent. Okay? So, in a nutshell, we have learned convex and concave mirrors. What is pole? What is center of curvature? What is radius of curvature? What is principal focus? What is focal length? And principal axis. Okay. So, thank you for today. Thank you for listening to me. Thank you for this interesting conversation. I hope to meet you soon.